Because accent is too huge or number of parameters is too much.
Did I tell everybody that we will be having class today? Folks online, we told, right? Yeah. It's okay.
Ask Arpita once maybe.
Just check with her.
She Arpita is online or just check?
Yeah, I'm here.
Yeah, she is online. Devi Prasad, I don't know. Okay. Yeah, so.
Sir, can you use it? I have a small data from Tally. Can you use that?
What is that?
It is content of YouTube videos in Grid.
Okay.
And where you can like, dislike against video ID.
Fine, I'll use that. So let me.
I'll maybe send them.
Send me to all, so that everybody downloads that. From the text processing part, I think we didn't do a few things, right? We did only one hot encoder, right? That day we ended class there, right? After that, we didn't do TF-IDF. I don't think I have discussed that with you. TF-IDF, text, date vectorizer, and all that. Fine. Just send me that. Till the time, I'll just explain those. Okay, so now what you have learned is, in a particular column, if there is one word, right, categorical data, that basically you can do the needful. But what happens? What happens when you have text data? That means one column consists of text review comments. Right? Text data. How do you deal with that? Okay, so for that we have several techniques. The easiest of them is count vectorizer. Okay, what will it do? It will, for each column, right? It will return many columns. Each column representing one word, and that will contain the counter how much time that word is appearing. Got it, right?
This is simple like that. I mean, just counting the word.
That's counting the word. It does not maintain the order of word. Okay, so I'll show some examples around it. You see here, this is a data frame. This is how it looks like. Of course, it can imagine it having multiple columns. This is one of the columns, right? As we understand, we cannot subject machine learning to this, right? Machine learning do not understand this text, right? So what you have to do is you have to convert them into, convert them into. See, we are creating a count vectorizer object, and we are doing a count vectorizer fit transform. Directly call so that it creates the mapping. It is creating the mapping. You can see here, column 0 is AND. Understood, right? So in this data, this particular row has AND in it, right? So corresponding to that, the value is 1. So cv.vocabulary, it will give you which column means what. Understood, right? CV, this is the count vectorizer which you have fit and train, and that will give you which column means what.
Then for all different words, it is choosing one digit, or how it is choosing 2 for something?
The number of times that word is appearing. So in this first row, second is appearing twice, right?
Yeah.
So you can see here second is column number 9. Probably this is second, so you can see it twice. Understood, right? This is count vectorizer. So, if you want to identify,
the number of columns that it has created, how it is.
For every word we'll have a column.
everybody will have a column. So you can imagine, if the number of words for every unique word there will be one column. So okay, so this is the basic way. But as you realize, this will explode given the number of words. How many words are there in English dictionary? How many words are there in
Words. Words.
You have no idea.
1 billion.
Depends from dictionary.
Generally 1.7 lakhs. Okay. So I mean main word. Okay, 1.7 lakhs. 7 lakhs. Of course, you have derived words out there. So now you have stop words here. Remember this stop words. What is stop words doing? Stop words means these, the and is. That means it will not consider these words. The and is does not give any context to that, right? You can still say food, good. It makes we understand what it means. Right? So these are stop words. Similarly, and if you mention stop words, see the number of words reduced, right? Here it was 12, here it became 10 because it is not considering this word. Again, you have default list of stop words like is, the, me, all this, not so significant word list is there that is present in English. Okay, so you can see the further number of words reduced, isn't it? So you need, the important thing is you need a lesser memory for representing the same data. We can imagine like Amazon data we have, it actually had 5.5 lakhs rows. So the number of words is very huge. Okay, you cannot have 3 lakh columns, not possible. Okay, so this is the second thing here. You have this count vectorizer. Count vectorizer and vocabulary. Vocabulary means you are telling here which words you are interested in. Understood, right? You are telling here which words you are interested in.
Like you do like something which is.
It has text in it.
Yeah, let me see that 2 things. Comment.
So whenever we want to search for any word frequency, we can give it under vocabulary.
Yeah, for example, you are doing the important thing to understand. If you are doing review analysis of some Zomato, which supplies food, so words like tasty, yummy, flavorful are important. Their words like late is not late, might be still relevant. Like coordination is less important. Whereas if you're doing for a bus journey, right, bus review sort of a thing, words like late, scheduled, behavior become more important. So you'll use them as your vocabulary. Understood, right? So that is why the analysis of bus review and food review would be different here.
So here, like yesterday, we explained this as a correlation between two words also. Like both of them exist, then what does it mean? And these things will also be done automatically.
Correlation,
like okay, if both of these words exist, it means like I don't know. Review means.
Actually, both of the words.
Too much impossible. I don't know how to put it.
Oh, got it. Multiple words.
Multiple words relating with each other.
Right. They're not so good.
Not so good.
Yeah, or if you write, amazing stuff.
How they'll do it.
Yeah. So yeah, you can do that. I was.
Sorry, comment is data is there, but it's a little big. 71.
I'll do text processing. I'm not doing it now. There's a separate thing. I'll do it in Nape-Base. Now I have to do simple. Okay.
Separate algorithm for that.
Yeah, I mean, not separate algorithm. You can still do that, but generally I do text because people, Nape-Base basically work well with text. Okay, so I'll use text data for there. Just I'm finishing this stuff.
Trend analysis like how the BJP or the political party, how many times they're talking. So they just filter based on the Twitter, how many times people type. This is the way or
sentiment analysis. Yes, this is the way. Okay, but I won't be doing any political analysis. I'll do food review and all that. Yeah, because I used to do that earlier. I'm told not to. So, yeah. Okay. So yeah. So here you understood, right? Vocabulary. Actually. So you have one more parameter, n-grams. N-grams. Okay, so when you use N-grams, you give possibility of multiple words. Got it, right? N-grams 2, if you 1 and 2, if you mention, it will take one word, or it will take another column, it will make 2 words. Where is it? Here by default it's configuring 1, so maybe I'll show it.
The people who are winning the Kaggle competition, do they actually work on a lot of APIs and try to understand which is best possible to figure out the answer, or it's like with normal the way we are preparing also we can do that and get a good score.
Yes, you can attend that. I mean, there are a few examples that I will show the data is from Kaggle only. Like they're one of the projects that I'll do, and it shows. I mean, whatever we'll do here, it will show 99% plus prediction accuracy.
And how do they decide like,
Who is the winner? The topper.
Maximum.
Okay. Okay, so I'll create some data.
It's in Europe.
Hmm?
You call it Osman. Not Kotlin, Osman. Yeah, not all that. Shopping center, small ones, not that big.
It's downloading the same data.
And the YouTube data is same, it is association or?
You can use some of the things for classification, but the good one is like the comment data that you have. Comment. Comment. Here you can say like but against the video IDs you can go for like dislike. There are dislike, there are like. Same video getting like, same video getting dislike.
But how do you classify?
It's like names you are there. That is, you have to use a little analysis like with author.
Same author, you get both like and dislike.
Almost for each video you are getting like and dislike.
Yeah.
Now, what is the probability of your video that will get like or dislike? Like similar to similar category, like the intention of the project, sorry, competition was not to classify everything, but something like when they are posting more number of videos. In Kaggle, they do not say like what exactly you have to do. They just give a brief idea what best information you can extract from that data is.
Yeah. But now, what we are going to do? I mean, just
He said like
from the last step,
no, he said like from
external
video you can. No, we are not using this one. We are not using this one.
I'm just loading to see after that. Okay, so to see what it is, right? The same data I'm loading now. This is the data, how it looks like. These are the tags. What is this title? First one is title of the video. Category ID. What is that you're predicting here? Oh no, this we can use for regression. Predicting number of comments, predicting number of likes. Understood, right? Predicting views.
Okay.
Yeah. And this is a very good data actually, because this is tags. You basically have to do the one-hot encoding of these tags, right? See here, the pipe separated tags are there, right? Okay, so I'll show the initial part here, but before that, let me just explain. Okay, so load the data in the meantime. This is YouTube data analysis. So all of you can do the same thing. You can try on some new data set. Okay, and whenever I have some fixed plan, I'll do that. If you, whenever I ask that, if you want to share something, you can do that. Okay. Okay, see, I have this review data. If I do review data.info, you can see here it is total 5,68,000 rows. Understood, right? Okay, so remember this, when you are dealing with larger data, right? Do not start working with whole data at some point of time. Start always with subset of data. Okay, so you basically should do this. Because if you use the whole big data, right? It is say 5 lakh, everything will take time. Failure, success, whatever it is happening, take time. You will not get a lot of experimentation bandwidth. So you should always, take a decent sample of it. If you mention sample and say, say 1,000 rows, that is what you're taking. Sample data. right? So this is the data, and remember, it has this text column here. Notice this. Okay, you can see the text column, right? So I'll deal with this. Okay, so yeah, but not, it will not be there. It's a huge data set. That's okay. You can Google for Kaggle Amazon food review data set. You'll find this data. Okay, so what I've done is, okay, so that's okay. Just search it and I can start downloading. It will take a few hundred MBs data, I guess. 190 MB data, right? Yeah. It will take downloading. It takes some time downloading it. In the meantime, you can see what I'm trying to do here. I have selected only these two columns, score and text. What is the idea? The idea is to okay, I'll show basic data transformation here. So idea is to predict the sentiment, whether the review comment means positive. This is how people identify whether the review comment is fake or genuine. Okay, so this is the score, this is the text, right? What you have to do, you have to, from this, you should be able to predict this. Understood, right? Is it clear? So, but we will not, see, 3 means neutral, isn't it? So 3 does not make a lot of sense. So basically should get rid of 3. Just one step. I mean, I'm just doing it some point to point some time now. Okay, so understood, right? Yeah. 3 means neutral, so it does not make positive review or negative review. It's a neutral review. Basically, want to get rid of that when you're training the models. So, how do you remove 3? Right. This is
not equal.
okay. So here you basically have dropped all the data, which is 3. And remember, when there is 1 and 2, you want to make it 0, negative sentiment, and 3 and 4 and 5, you want to make convert into 1. Understood what I'm trying to say? Right? So you have to do the transformation as 0 wherever you see 0 and 1. So we have to write some pandas code over there, right? Right? So I've written a lambda code. If it is R is less than, I mean, each element is less than 3, it will become 0, otherwise it will become 1. And you basically want to overwrite it. Right? You can see.
One more encoding, right? That's what you
No. I basically, I mean, this is basically data transformation. I mean, 0, 1 and 2, you basically did that. Right? Because you want positive, like, 0 means negative reviews, 1 means positive reviews. right? So this is the data transformation that you have to do. Now the next thing is okay. Now the next thing is I want to get. I mean, of course, I cannot apply logistic regression also if my data is like this, right? I have to do some conversion of this data. So first of all, remember there is a lot of there is a lot of stop words. I mean, basically English. I mean, is, the, all those things are there, right? We do not want them to consider. Okay, so we can use count vectorizer.
Which are the stop words? Which are the stop words?
Pre-processing. Yeah, sorry, feature extraction. Dot text import. Okay, so see, stop words are the words that are not important, like is, the, and all that. Understood, right? Okay, so I'll use count vectorizer. So CV is equal to okay, here you will pass stop word C, stop words English, right? So that it does, I mean, based on English dictionary, it does all of them. Then you have n words, n-grams. N-grams is what you're saying. Here you can mention what is the range of words 1 and 2. It can do 2 words also at a time, right? 1 and 2. So this is, of course, vocabulary range. Vocabulary I'm not passing here. Everything else become vocabulary. If you do x is equal to cv dot fit transform
Sample data.
This column actually sample data dot text. Understood, right?
Okay.
Right. If you do X shape, you can see here the total 921 columns. How many rows and how many columns are there? 34,000.
Lot of parameters.
Yeah, a lot of words. Right? A lot of words. I mean, if you really want to understand which word is which column, you basically would do this, right? CV dot right. This means this is the word, this is the column, this means this is the column. Understood, right? Is it?
Mapping.
The mapping. And you know, as we did n-gram, so you know, you'll see 2 words also. Did you see 2 words? Help, really, right? And so if I dump the data 34,000, it will actually, each column will represent 1 word or the combination of 2 words and the counter corresponding to that. Make sense? Okay, but what is important to understand here is you are not taking care of the context of the word. It does not matter where the word begins. In a sentence, in this method, the context is not taken into account. Did you notice that?
How you will take that into account? Like there is a separate
Context will be taken in account if you are using deep learning and all that. NLP, then we saw that, right? RNN, yes. Because these algorithms are not context-free, context-based algorithms. Okay, it just takes each word and a combination of one and find out, you know, what type of sentiment does that word is contributing. Okay, understood. What is this is the first technique, the count vectorizer. Next technique is TF-IDF. Okay.
Sir, when you're saying like help really, for an example, right? Is that trying to understand help really is making a sense or not?
No. Help means.
There is a help really 2-word.
Right.
Is that trying to understand whether it makes a sense?
What is it contributing to? I mean, this becomes a number actually. what has happened now is your data has become number completely. Okay, X, right? If I do X dot, okay, so you can see here dot dot. What is the shape of it? 34,000. It's precisely dot dot because it's a lot of data here. Can't show. I'm just dumping to. Don't dump the entire data. It will block it. Just during to. Okay, so there's this. So what you want to? This is the X, right? So what you want to do? You want to combine your the other values, or anyway, this is your feature data. So this is what it is doing. If you have to combine other columns, you'll use NumPy H stack, right, to combine other rows. Clear, right? NP H stack, horizontal stacking. You basically, this is for one column it is converted to this, right? There might be other columns which is numerical in the data. You basically have to combine to this data. What will you use? H stack, NP H stack. That is where you need it. Right?
This is the row, right? Second row.
Yeah, this is 2 rows I'm printing. Of course, now with along with this, you have any other column to be added to. Understood, right? Any other column means you have to add one column. So you will use NumPy H stack for that.
So you can add that column.
Right? So here it was word count based. Now you have another technique which I might not try to code now. Okay, that is your TF idea vectorizer. Okay, what will it do? It will actually, given the above word, it will find how much important that word is. For example, you have corpus. There are few terms that you need to know. If you have corpus means collection of documents. Right? Corpus means collection of documents. Okay. So when it is collection of documents, what happens is, okay, you have collection of documents, and now just take an example of Wikipedia documents. Suppose you have Wikipedia documents, okay, Wikipedia pages. There, if you see the word Obama, okay, now Obama will be there in all the documents? No, right? It will be there in the limited documents only. And that is why this word is important. Compared to a word like the, is, which is present in all the documents. Okay, so there the number of words that is present is more, is the, if you do count vectorizer, that will be very high, isn't it? Right? But if you do TF-IDF vectorizer, it will give you the importance of the word. Right? TF-IDF vectorizer will give you importance of the word. Okay, let's take the previous example. In this example,
How you decide?
how you decide if the word is more frequently occurring in a document compared to the entire corpus. Document is one Wikipedia page. If the word is like in Obama's document, Obama article, Obama will be there multiple times compared to the entire corpus. Then the word is more important. If there is a word that is appearing in the document also less than the entire corpus, like then the word is not important. This technique is known as term frequency inverse document frequency. Term frequency in one document, how many times that is appearing, inverse document frequency, how, and its relation with respect to the entire. Okay, so this was TF-IDF.
So entire, when you say it's the data set of your scheme or what?
Entire data set. Like, in this example, if you see here, this is the data set, right? This is the data set. So if I do TF-IDF for this, you can see here, first TF-IDF, then I am using the stop words. Stop words will remove all unnecessary words, right? We have only these words. After doing stop words, I have only these words left, right? And you can see in the second line, the second word becomes very important, and all these values will be between 0 and 1. right? So in second line, the second word is very important. The reason is the second word is coming here twice compared to the entire corpus, isn't it? Right? So the importance of this word is very high. Is it clear?
I didn't get the point.
So this word second line, you can see the second word, right? Okay. So what is second word? You can see here, this is get feature name will give you which column means which word. So you can see this column, this is the last column here, isn't it? Right? Last column is second. So, and this is second data itself. So you can see here, just because second is not appearing in anywhere else, it becomes most important.
Simply comment.
Huh? Yes. So if I do this with, the earlier count method, it is basically based on how many times a word is appearing. Okay, and that precisely can be a misleading element because sometimes unimportant words get repeated more times. Okay, is the and all that. To prevent that situation, you use this EFIDF. Clear?
So when you mentioned something, just can you scroll down, sir? There is one. Get this stop, not the stop word. Yeah, stop word English. What does that mean? Stop words English.
English, that is alright. I mean, based on English dictionary, it itself will tell you which are the words that is not important.
Not important.
Understood, right? Like is the that based on English dictionary. Otherwise, we can write our own also. Stop words the user.
Okay.
Okay. After this, this is pretty useful hashing vectorizer. If you have a lot of words, I'll show that actually. Okay, so. Okay, hashing vectorizer. Hashing vectorizer means here you can see how many words is it, how many columns it is creating. 34,000 and all. Just 1,000 rows I passed here, right? Just imagine if I pass 5,60,000 rows, what will happen? It will explode. Basically, if you go for 3-4 lakhs columns and all that, it's not practically possible to do algorithms on that. Okay, so what you do, you have a method that is known as hashing vectorizer. Hashing vectorizer. Okay, what it does basically, you tell it number of features that you're limiting to. You pass a text to that, it will convert that into 5. Right? No matter how many words are there, it will bucketize the data into 5 columns. Understood, right? That is multiple words will go to one column, and this is basically telling you what is important.
So multiple words they're clubbing it together,
right?
And then it goes to one column. How will they do it actually?
Like there and the, it will make it one column.
Which are not so important.
Not so important, not similar. I mean, it will now the algorithm will do that. Okay, so what will it do? It will actually find out 2 words which can be fit in the same bucket. Okay, maybe similarity between the words.
Okay. Just reduce the calculation.
And reduce the calculation, reduce the size.
So when you are doing this and extracting 5 columns, for an example, you are creating 5 categories, right?
5 features, 5 columns.
5 features, variables you are saying.
Yeah, so I'll show it then.
From that, what are you going to understand? From that, what are you going to understand?
I'm just showing it now. Suppose I give here 1,000 columns, right? It's not really a matter of understanding. Here you can see here, it is returning you 1000 columns. How many you want to rows, all the columns, to array. So basically your whatever output you get here, right? It's not that you can understand which words got here. Basically, you don't need to understand. It is vectorizing it. You're doing it just because the words are too much. Okay. And after, so this is output. This is similar as above, just that you don't have a lot of other APIs.
So Avantik, it is not compressing the data, right? Like when we
It is reducing the bucket. That's what I'm saying. You know, 2 words is getting into 1 column. Understood, right? It
okay.
figure out the best way to do that, and yeah, it's getting to it. It's sending 2 words to same column actually.
What you mean to say, like if we take all unique words into one column, then it will be a huge one. So what you are trying to do is you are compressing.
See, all you're trying to do is you cannot afford 34,612 columns here.
Those many unique words are there.
Not unique words. Those many unique words are there previously.
Yeah.
Right, and now what you're trying to do is that 34,000 words, you are trying to find 1,000 buckets to store that.
There is some way it is trying to.
Some way, like singular words or some maths it is doing, somehow it is storing it and it is working out. Okay. Understood, right? Hashing vectorizer. So you do this when the data is too large. When the number of columns goes beyond a point, this is the thing that comes handy when scaling.
How will you come to know that 1,000 things? Like, it will be so big data set. So how will you know that all the words are filling up?
You will not know. You basically would give it some number by 1,000.
No, you might miss something in words, right?
No. It's not really missing the word. You are finding one column or 2-3 words.
So it will fit in for everyone.
That's like a polynomial degree. You do with the 500 and 1,000, 1,500. And you match. So we are matching your results so that you decide.
The results.
So now finally we are going to find the like or dislike based on this.
Yeah,
The
now.
1,000 is giving good prediction. Maybe we can start with the 1,000 itself. Or
Yeah, that is also possible. But
to what extent you will be able to do that? Because the total number is 34.
Generally, people. I mean, I'll tell you a general number.
Yeah.
Generally, 10,000 people take as number of columns. Okay, if the data set is large, 10,000 is a decent number of columns. You basically might not do this type of, you might not use hashing vectorizer with this. DF-IDF gives a good result if you are using important words. Right. So we'll do this in Amazon Photo View. Okay, let's not jump the guns. So now, basically, I will go for the. You understood, right? Reading text. One more thing before I can close the transformation part. There is one, custom transformer. Custom transformer means you are creating your own transformer. Understood, right? Okay, so basically, this is the transformer function. You can write any function that you want. Right? It is decided in function transformer. It is you are creating your own transformer. Right? For each element that you pass, it will add 2 to that. This is the data, and you are passing that data here. It is adding 2 to all of the elements. Clear? Okay, this is how you create your own transformer. You might need to. Not always everything that is available will be solving your purpose. If you need to, this is what you can. Okay, so remember this. We'll use this later. Okay, let's start solving the problem. Everybody has loaded the YouTube data. Okay, so we have to deal with this with column by column. Actually, this is a lot of work you have to do with this data. Okay, so but what is the first column? First column is the people have tagged the channel title itself in the first column. Notice this. Not always, right?
No.
Oh, these are the tags in that stuff, right? These are the tags. So first, what you should do, you should deal with tags first. So you can see here, these are the tags. How many tags are here?
Avantik, which data is this?
I think Niladri sent mail to everybody. You did, right? So there you'll find some YouTube data actually. Okay, this is how it looks like. Right? It looks like you have video ID, which is not much useful because this is just an ID. But what you can do is you can try to predict. This is a regression problem actually. Okay. What you can predict is typically I'll do this data or info. Right. So the data is pretty small, 7,900. And what you have is this is the last one is date or what?
The last one is date, but not proper format.
What is 13.09?
No, that is the
2013 and September.
Like that. So we change to YY.
Right, not DD YYMM. And comments total, thumbnail link is anyway useless, so you can get rid of that. What are the columns that you think is totally useless? You can get rid of that. One is, I think, thumbnail link, and other is video ID. No, category ID is important, right? You want to predict, number of comments that is coming to a page. The category, if it's sports, or if it is number of comments is less, it's quite more in sports or in movie sort of a thing, right? Compared to technical things. Okay, and the title and tags need some dealing here, right? Okay, so let me deal with title first. See all the steps that I'm doing, and this is a good example of dealing with text and all. Okay, so what I need to do is from each tags, right? I want to, but there are tags with multiple words also, right? Okay, so guys, so there are few things we need to take care here. See, first I was thinking of, just remove, pour in your thoughts also, I mean, at the same time, right? So you can see here this pipe thing here, right? That makes us understand these are different words, right? But we cannot do one thing, we cannot simply remove this pipe and maybe because holy, whatever is it, right? Emma Blackberry, suppose you have, so, and you have Emma Blackberry, we want actually all this to be different words, isn't it? Sprinkle of glitter. You have sprinkle of glitter and sprinkle of glitter. People want to tag with that as well.
There's some tag it is good, like how to cook it in this recipe kitchen.
First we feast. FWF, first we feast in the same thing. So you have, I mean, this is, yeah, but these are some real challenges here. Right? I mean, this data is given in YouTube because here the text processing is little difficult. I mean, YouTube means in Carol because it's so okay. So you have to deal with this particular text now. So what is the strategy that will take? Yeah, but what will you consider as one word? It should connect charger. Understood? Everybody loaded the data? Path, check the path and all that. Okay, so I'm thinking of a strategy. What will I do is, I'll just combine, if there is a space separated word, I'll just combine them first. Okay, and what will happen is there will be words which will be repeated here. You can see like, first we eat and these words will be repeated also. First convert each word into smaller case, then combine them. Then remove the duplicates. Right? That can be one strategy. Okay, then remove the duplicates, and that will give us the minimal subset. Then we use our one of our technique. But here, since these are tags here, the chance, these words will be mostly nouns. It won't be, words like, este, I don't know what is this. It's some, it's a music. Okay. Okay. Yeah. So that's the whole drill around it, right?
A lot of Eminem stuff out there. Might be they have read for something.
Achha. Okay, fine. Okay, so this is the deal. This is what we will do with tags. Okay, that's the plan. Okay, because you want to shrink it up, right? You want to make it one and then remove the word which is appearing twice. Okay, we'll use pandas for that, right? In map function, this is the thing that we'll do for that, right? So you'll write a map function here. Understood what you have to do? You have to remove the pipes, convert each word, combine each word inside it, and remove duplicates out of it. Right? You can note down, this is the first action item.
We segregate by Using the pipe, right?
So combine words within a pipe. I'll write it here. Combine words in pipe. No duplicates.
Small letter. Small letter.
Remove duplicates. Make it on
So you are considering only one column for the analysis, that is the tag one, right? You're considering only the tag column for analysis. So you have taken it in the data from the data.
Right. Okay, so this is what we'll do with it. Let's write the entire plan. Okay, then okay, so what is the next thing that we'll do? You don't need thumbnail link. Is there any other thing? Yeah, that first was title, right? Title also you have to do the same thing. Title you better use your TF-IDF. Okay, because some this is the title of it. Small case TF-IDF. You have to use that, the title part. Okay, so there are some channels. So channel title is also important. So you can see channel title. You might have to use, you have to do label encoder, right? So that each word gets one number, right? This is all different channel title or it's same?
No.
The repetition is there, right? Let's see that why to make cases, right? How to get that? Value counts. Yeah, repetition is there, see? Yeah, so we should never make guesses just by reviewing the head file, right? You see, repetition is there.
Title is also there.
So this is the title getting repeated. So you should do one hot, not one hot, label encoder here. Note it down. You have to do all this activities. Right, one label encoder here. Then a channel title here. Okay. And title I think would be different, is it? No, title also there are repetitions, is it? Right? So title also there are repetitions. Title is a name of it, right? So title also you have to do label encoder. Yeah. Understood? And after you have done all these things, you have to label encoder. No, that is not required. And after that, you don't need date, you don't need thumbnail. Based on the other information, you have to calculate comment total. Understood, right? You have to divide the data into train and test. After doing all this, divide the data into train and test, train the model with that, then validate with this. Understood what the process is that we'll do?
First, like you said, based on that pipe, will plot the multiple words, and then we'll convert that into
Right, then you will remove duplicates from there, right?
So we have to work with 3 columns: tags, title, and channel title. That's it.
Tags, title, channel title, views, likes, dislikes.
The views like this.
You need it for a comment total, right? Comment total is very much dependent on views.
No, but we do not have to encode or do any kind of thing on those columns.
You don't have to. You just will use them directly.
Directly.
Okay, it's the regression problem, right? And you are trying to predict comments, total number of comments from the data.
Thumbnail.
Comments, comment total. Thumbnails you don't need, date you don't need. Got it?
Then this category ID and video ID.
With category ID is required. Category ID is
Where
required.
do we classify to the
Which
different
category does not belong to? The video ID is not required, of course.
Video ID is just like whenever you're uploading a video ID is
Right? So do this step by step. Okay, do this step by step. I think today you'll find this code uploaded. But I'll not upload it today. But try give it a shot. I'll show the code tomorrow's class, and then I'll upload it. Okay, so till from today to tomorrow you have time to do it. Right? As you can see, the trickiest part here is to deal with tags. And you now know what to do, right? Use map and do the code, write the code over here, see, spend some time over it, and see how much accuracy are you getting. Okay. Okay, so Kaggle has one more popular data set. Okay, this if you happen to finish this, then there is one more problem that you can try. This is attrition data. Okay, this also you can find in Kaggle. This is the attrition data, and you can see, basically this is a whole project here. Okay, you can see this employee data analysis. Okay, I'll just zoom up. So the data is HR comma separated, and this is the data: satisfaction level, last evaluation, number of project, average monthly hours, and you have one column here, left column here, whether the person left the organization or not. Right? You have this is actually a department. This is a wrong name, so we change the name. This is a wrong name. This should be department. Okay, and this is a salary, low, medium, high. Now, when you are plotting the data based on, you understood the data? Let me show download the data. You can also do the same. Kaggle employee. IBM HR. Anybody from IBM here?
how it is posted in Kaggle when it is a company specific.
Hey, where is the YouTube room? Try to find out YouTube video.
It is very small.
Yeah. Mitchell J something. Mitchell J.
Okay, so this is the URL if you want to see some existing stuff. Okay, you can see it is doing, what this code is doing till the time it gets downloaded. It is actually show, how many, a lot of people with 3 projects, a lot of less people with 7 projects, right? So note down this URL and go through this. Average monthly hours, this is a distribution of people. You can see people who are the people who are less satisfied. I think we did this exercise, right? India.
We are trying to see.
Ah.
But just giving Matplotlib.
Right, Bangalore. So here you can see these are the people who are less satisfied, people who work more have less satisfaction. Got it, right? That was the analysis here. Then you basically see, I'm doing it now. These are the columns. These are the text columns here, right? Label encoder and department and salary, right? What I'm doing here, I'm using label encoder here. I'll explain data frame mapper and all that. Okay, but I'm just explaining now. Label encoder means it is converted now into numbers, right? Now you see you have different algorithms here. The XGBoost and all that, and eventually you're finding 97% accuracy. Just the small code, but the flow. First you actually do this, do some basic data analysis, understand what is important. Then next part, do the data transformation that is required. In the last part, you actually do the prediction.
The pipeline we have to complete.
Pipeline we have to go. I mean, this is like automated code in the sense if you are using pipeline, and these are the topics that we'll discuss next. That's why I'm not doing this for it now. Okay. So these are the topics we'll discuss next, which will actually help you writing a reusable code for pipeline and all that. But that's one part of it. But first you try to focus on whatever learning we have, you use it.
How do you know this is the best code?
Accuracy. You remember?
One is the best code. 100 is the best. One is the best code. Then I don't think the complex data will be able to get one score.
Yeah, of course you won't do it.
Then how do I know
still, I mean, there is no absolute best. There is no absolute best. So you have to, if a lot of people are trying to solve and this is the best number you're getting, you can say this is the best. If anybody has better idea, you go before, your answer goes before it. Right? So that's why all the Kaggle problem that you see, a lot of things are solved, but you'll notice that
still they are trying to update that.
Right. That is where the scope is. Okay, let's assume that my HR data of IBM is downloaded.
So can we find the competition data analysis in Kaggle? Competition data analysis.
Competition data.
Like whatever competition they're posting.
It is there. You may have to find, but it is there. Let me load this file. Okay, so pull out some data from information from Kaggle, import pandas spd pd dot read csv. You can see this is the employee data. Oh, nice. This is good data. Data set is small. So attrition is here, right? This is the column that you have to figure out. Attrition, yes, the person left, the person didn't leave. Understood, right? So there are a lot of columns. This is a, there are a lot of columns in which you have to do label encoding, isn't it? What are the columns? You have to take care of business, travel, and department, education field. That's it, right? So these are the columns. So
Hold on, there are so many. There are 35 columns.
oh, the middle one I'm not able to see, right? So to do that, you have to do this.
Explain info.
Okay, everything which is object here.
1, 2, 3. Lot of
Just convert them to numbers.
8 I think.
9 objects. You can convert them to numbers.
Numbers, it. Business travel is there. Department is there. Education field is there. Okay, so what you have to do? You mentioned here cat calls.
One time code is like that column unique columns equals to take a small example.
Overtime.
For example, 0 to 4, 3 numbers. 3 words are there. 2 words.
Over 18. Okay, I'll show this step. I want to write a single line which will, of course, right? This is what you can do. You want to see one thing. There's one way to do otherwise as well. Okay, so marital
Can
status.
you suppose something like employee data wherever data type is object?
Object. Okay, so the first one you understood, right? You create a list of all the values in it and do that. And if you want to do this, employee data, if you do this, you will get all the columns.
You have to also use to object.
No, object is not a type.
You have to do that.
It is giving you the type of it.
Now, you equal object block.
So here these are the right. You are getting. I mean, I don't know why that was not given within codes, right? So here it will give you the columns which has object in it, and you want to filter out that columns. EMP. I think I have to do list because it is index. Oh, it's giving it, right? Yeah. These are the columns which is strings here, right? Categorical columns. Cat calls. Right? And do this to list so that it is converted to list here. Okay, these are your cat calls. Okay, now what you have to do for this categorical column, you have to use, you can see a label encoder you have to use, right? A label encoder or right. So what I can do SQL reprocessing import label encoder. Okay, so what should you do for all the columns? You should be doing this, right? For all in get calls. Okay, employee data and right, for all the categorical column, it will directly change in one shot with this line. Right? Now if you see employee data, all data change to numbers. Right? All data change to numbers. I'm not doing any feature selection and all that. Okay.
Do we need to do scaling? For example, daily rate is pretty much high.
No, for regression techniques, you don't need scaling. So we all you need to do is predict this iteration. Right? So what you can from scalar dot linear model import logistic regression LR is equal to logistic regression and dot fit result employee data dot drop.
One thing just when we use the earlier we use kind of different education means we put one. The education is school one, and the education is college, then we put the school as 0 and 1. That is one way we do, right?
Or not encoder.
Yeah, encoder.
And you could have actually few of the columns you could have done one hot encoder.
What is it?
One hot encoder, right? Education, right?
Yeah.
Right. Anyway, education. So if you want to give some ordinal importance, right? You want to give high school as higher important than primary school. Got it, right? You'll do it increasing order. Understood, right? I mean, those are the things you can do, right? So that you give ordinal importance to the data. Okay, now I think it is taken care of, but if not necessarily this way. Okay, so you might have to do that. First, I just want to see, without doing a lot of things, what is the baseline result. Then I'll tell you some improvements to do. You guys can do that, and based on that, you can see how much are you improving. First, create a baseline thing. Okay, without doing anything, this is what I'm getting here. Okay, so employee data dot. Okay. This is basically, your model has been trained. LR dot score. You're getting somewhere, and I'm using the same data for training and testing, which is not a wise thing. Okay, so what I should be doing, I should be splitting the data into train and test. Okay, so if you right, that will give you the real accuracy what is happening. But you got the flow, right? What we did here on the simplest data set. Right? So how you should complete this task. Note down what are the things you have to do. You have to first do data analysis on this data. Okay, that means I identify what are the number of projects people are working in, like what are the questions that can be formed here, right? I'll tell you one of them, rest you have to create. How does it matter if the person has to travel a lot? Because there is data like, okay, a lot of, right. How does distance from home matter? How does education matter? How does the relationship matter? How does stocks matter? How does training time last enough? How does work-life balance matter? To find, what is the relationship between this and iteration.
One will be the iteration and other will be what are the important variables which are impacting iteration.
You basically, that's the whole journey here. You basically have to do some sort of data analysis here to make some sense. Then, after this data, you'll figure out there is something more important than this. You're not doing any feature selection as such, but you'll automatically see some things are more important than others, right? Then you can use those and only split the data into train and test, and then do the validation there. Right? So to start this journey first to get this feeling, you have to understand this data, you have to tell some story, do some conclusions here, this is what it means. This is employee, everybody got access to this data, right? Do this, start with this data, then go for YouTube, start with this because it's easier. Okay, then spend some time, not necessary, you might be able to finish this today, not possible. So plan this over the weekend as well, and start doing it so that tomorrow when we start maybe a decision tree, okay, not decision tree, we'll start pipelining, feature union, all these concepts will start so that you will be able to write more easier code over the weekend. Okay.
Yeah, I mean.
These videos will be uploaded.
Videos.
That's very important.
Okay, I'm making the meeting. Let me upload yesterday's at least.